So in this video, we're going to continue working about solving linear equations, but now we're going to throw in a little something about solving special systems of linear equations. So here's the thing. We've covered three different methods about solving systems. One, graphing it manually. Again, I should say four, because I included the calculator. Graphing it manually, graphing it on a calculator, using the process of what we call substitution, and using the process of what we call elimination. Now, so if I were to give you a system, there are one of three possible outcomes that you could have. One, you could have one solution, and that's what we have been doing in all since the very beginning of this chapter. We have been finding the system of equations that have exactly one solution. That's all we've been doing. So the two that I'm adding to you now is what we call no solutions and infinite solutions. So let's just kind of walk back and do a little bit of review here. So in the previous videos, I gave you a system of linear equations and I tell you to graph it, solve it, or however. And when you graphed it, you would get something like this. You would have your coordinate plane and you would graph your two lines, and your lines would literally meet at a intersection, and we would find that ordered pair to be, say, 2, 3, or whatever number it might be. This is one solution. This is what it looks like on graphing. Algebraically is what we've been doing through the substitution and elimination. All that work that we do through both of these types of processes leads to the simple fact that the line algebraically will cross at 2 and 3. All right, this is what we have been doing in the past since Section 4.1. So that's nothing new to you. This is where it's a little bit new. If I have a system of equations and I graph it and it looks like this, where I have two parallel lines, it means that I have no solution. These two lines will never cross because they are parallel. Therefore, it is no solution. However, we can also prove this algebraically. First off, look at the equations. You remember y equals mx plus b? Hopefully you do. If you look at that equation and you notice that the slopes are equal for both of those two equations, you don't even have to do any more work. You can say, hey, there's no solution because the slopes are equal. Well, what if you didn't notice that and you started doing things through substitution and elimination? You're going to come up with an equation. You know how you would get normally when you did something, you might get something like x is equal to 1, or you might find out that y is equal to 2 or something like that. Well, if you have no solution, you're not going to get that. You're going to get something weird looking. You're going to get a number that's not equal to a number. You might do all the work and all of a sudden you might end up getting 2 is equal to 5. That doesn't make any sense. This is a lie. A cannot equal B. Therefore, if you ever do your math algebraic way of doing things and you come out with that these two numbers don't match, then you have a no solution. All right? Now, infinite solution. When you go to graph the two equations, you're going to find out one simple thing. They're the same line. Both equations are right here. They're literally the same thing, which goes back to the algebraic part of things. If you notice right off the bat that the equations are exactly the same, then your answer is infinite solutions. If you didn't notice that because of some weird thing or whatever, and you did things through substitution and elimination and you worked it out, you're going to see something like this, where one side of the equation is literally the same thing as the other side, such as 0 equals 0, or maybe -5 is equal to -5. So if they're literally the same thing, it's infinite solutions. But if they're opposites, like this, or they don't, or it doesn't make sense when you've done all the work, it's no solution. So let's just go ahead and do a few, just to kind of show it. So right off the bat, let's look at number 1. It's already in mx plus b format, slope-intercept form, and right off the bat, let me tell you what I see. The slope of this guy is 2, and the slope of this guy is 2. So right off the bat, I can tell you for a fact that there is no solution for this problem because these two lines are the exact same slope. Therefore, if I were to graph it, it would look very much like this. It would be a parallel set of lines. However, let's pretend I didn't notice that. And let's use process of elimination or substitution. Let's use substitution. I know right now that this one right here, this y is equal to this expression. So I can put that right back into this one. So I can say 2x plus 5 is equal to 2x plus 7. All right, now let's continue to work it out. We're going to solve for it. So I can subtract 2x from both sides. And what I do, that cancels out, and that gives me 5 is equal to 7. Wait a minute, that doesn't make sense. How can 5 equal to 7? You're exactly right, which goes back to what I said before. This didn't make sense. So that means there is no solution. All right, now let's try another one. We have this one. Right from the get-go, I can't tell anything about it just by looking at it right off the bat. So the best thing for me to do is to probably go ahead and do this algebraically speaking. So because I see this, I see that y is equal to this expression, I'm going to use substitution. And I'm going to plug this expression into this equation. So 3x plus 4 times negative 3/4 x minus 5 halves equals negative 10. Oh boy, this is going to be fun. So I'm going to 3x, and 4 times negative 3/4 x is going to give me a negative 3x. And 4 times a negative 5 halves is going to give me a negative 10 equals negative 10. Well, 3x minus 3x, when I combine those like terms, is 0. So that gives me 0 minus 10 is equal to negative 10. Well, 0 minus 10 is negative 10 is equal to negative 10. Stop. Wait. That doesn't give me an x equals. This says negative 10 is equal to negative 10. These two things canceled out, and that's okay. That means, guess what? These things, according to the rules here, are infinite solution, and it means that both of these equations are the same equation. Well, Mr. Lewis, how is that possible? How is this and this the same equation? How is the answer to this thing infinite? Well, I'm going to prove it to you one more way. We just proved it this way, that when we set it up in substitution, that it equals to both sides. Let's do it one more way. I'm going to look at this by itself. 3x plus 4y is equal to negative 10. You don't have to do this, but this is just another way to prove that these two are infinite solutions. What I'm going to do is I'm going to solve for y. And in order to do that, we SADMET. So I'm going to subtract 3x from both sides, and I get 4y is equal to negative 10 minus 3x. Now, I'm going to divide by 4 on both sides. And I get y is equal to negative 10 divided by 4 minus 3/4 x. Well, let's keep simplifying this. Y is equal to negative 5 halves minus 3/4 x. And because I like my slope in the front, we can use the commutative property of addition. And y is equal to negative 3/4 x minus 5 halves. Wait a minute, that is literally the same equation that I have here. So I could have done it that way. I could have set it for y and noticed that they were the same equation. Either way works. All right, so why don't you take a chance and look at numbers 3 and number 4 on your own. So for number 3, if you work this out, you should notice that this is an infinite solution. These two are the exact same equation. And for number 4, you would have realized that this is no solution. If you had worked it out, you would have got that. And if you had set them both equal to y to see if to look at their equations directly, you would have noticed that they had the same slope. All right, so number 5, let's take a look at this one. You start reading a book for your literature class 2 days before your friend. You both read 10 pages per night. A system of linear equations that represents this situation is y is equal to 10x plus 20 and y is equal to 10x. Will your friend finish the book before you? Justify your answer. You know what? I'm going to leave that one as a challenge problem, okay? I'm going to actually leave that as a challenge problem for you, all right? And why is that the case? All right, this is a good one, all right? That one I'm not going to do with you because I like it. 6, you and your friend buy music from different online stores. The system of linear equations represents the total amount spent on songs and albums. Both of you buy the same number of albums. Compare the number of songs each of you buy. All right? So, let's look at that one. That's a good one. That's something different. So, you and a friend buy music from different online stores. The system of linear equations represents the total spent on songs and on albums. So songs and albums. Oh, I didn't realize off screen. I'm sorry. So this is X is songs and Y is. So on 5 and 6, I'm going to leave 5 for you, actually. That one's actually a pretty easy question, but I'm going to let you think on it. Please ask me about that one if you get the opportunity. But let's talk about 6. You and your friend buy music from different online stores. The system of linear equations represents the total spent on songs and albums. So X represents songs and Y represents albums. Both of you buy the same number of albums. Compare the number of songs each of you buy. That's very interesting. So according to this, you buy literally the same amount of songs. So what it's telling you is that the best thing probably for you to do is to actually to find this out is to make an assumption and that both of you get this, your Y is going to be exactly the same thing. So let's do this. What we're going to do is, since you both bought the same Y, let's go ahead and solve each equation for Y, just out of curiosity to see if they are the same all the way around. So let's do that. So I'm going to actually get a little bit of scrap paper here and work this out on another sheet because this is not enough room. So I have 0.95x plus 10y equals 39.5. And the other one I have is 1.9x plus 20y equals 79. So what we're going to do is we're going to solve this by using elimination or substitution. And here's what I'm actually going to do. I'm going to do elimination. And here's the reason why I'm doing it. Notice this. This has a 10y and this is a 20y. That means I can actually multiply this equation by 2 and get them to have the exact same coefficient. So 20 times 95 cents, I don't feel like doing the math in my head. Actually, I just did it that quick, but oh well. It's $1.90 times X plus 20Y is equal to 39.5 times 2 and gives me 79. Stop. Wait a minute. Now that's very interesting. I multiplied this by 2 and notice what happened. This equation is exactly the same as this equation. What does that mean? It means that there are infinite amounts of solutions, and not only did I buy, it says we both bought the same number of albums, but since they're the exact same equation, it also means that we bought same amount of songs. So by just solving that, we realize that they are the same exact equation. So you and your friend bought the exact same thing. Nothing's changed. All right, that's the end for this video. As you can tell, my voice is getting weaker and weaker as the day goes by. And I will see you in the next video. Bye-bye.